This series of videos will be about section 4.2 in college algebra and context, combining functions and composite functions. For finding the sum, we need to find f plus g of x. Basically, we take f of x and add g of x. And here's a sample here. So f of x is the square root of x, and g of x is x cubed. So it just becomes a square root of x plus x cubed. Difference, f minus g of x is f of x minus g of x. So this becomes the square root of x minus x cubed. F times g of x is f of x times g of x. So it becomes the square root of x times x cubed, which is normally written x cubed times the square root of x with the radical part last. The quotient of f divided by g of x is f of x divided by g of x, and of course g now being in the denominator cannot equal 0. So it would become square root of x over x cubed, but x cannot equal 0 because x equaling 0 would make the denominator equal 0. Let's try these on some actual problems. So here our f of x is x cubed and our g of x is x minus 9. Find the following functions and give their domains. Well, the first one, adding, so it'll be f of x plus g of x, and this will be our answer, and our domain is all real numbers. For f minus g of x, we'll take f of x and subtract and make sure you put in parentheses g of x, because when we remove our parentheses, it makes it a negative x and a positive 9. So this becomes my answer. The domain, again, is all real numbers. Using the same two functions, we want to find their product. Notice this is a filled in dot. So it'll be x cubed times x minus 9. Removing that parentheses, it'll be x to the 4th minus 9x cubed, and the domain is all real numbers. And then dividing, it will be the f of x over the g of x. So this becomes my answer, but for domain, we know that the denominator cannot equal 0, so x cannot equal 9, and then it's all real numbers except that. Written in interval notation as negative infinity to 9 parentheses union with 9 to infinity. This is how you write interval notation to just skip one number. Now let's actually use those sum difference, those operations. The demand for a certain electronics component is given by P of x is 1,000 minus 2x. Now remember the demand here. This is the price that people will pay for it. Producing and selling X components involves a fixed monthly cost of $1,599 and a production cost of $3 for each component. First, we run a right equation that model the total revenue and the total cost as functions of the components produced and sold each month. So we're going to do X components is what we're selling. Well, the revenue then would be the price we can sell them at times the number of components. So that will equal 1,000 minus 2x times x, or my revenue function will equal negative 2x squared plus 1,000x. My cost function then, well, the costs are $3 for each component, so 3x, and then plus that fixed cost of $1,599. So here's my cost function. Here's my revenue function. Now, same problem. We want to write the equation that models the profit. Well, capital P for profit equals the revenue minus the cost. So our revenue from the last page was negative 2x squared plus 1000x, and then we want to subtract the costs that were 3x plus 1599. We'll remove parentheses and combine like terms. 2x squared plus 1000x minus 3x and minus the 1599. So my profit turns out to be negative 2x squared plus 997x minus 1599. And this is my profit function. We want the maximum possible monthly profit. Oh, well, and the profit function we just wrote was negative 2x squared plus 997x minus 1599. And finding the maximum possible profit means I'm going to be finding the vertex. The x value of the vertex will be negative b over 2a, so negative 997 over 2 times negative 2. That turns out to equal 249.25. Since we won't be producing only part of a component, I'm going to change this to 249. And we want the profit, so we really want the y value. Finding that, I will take my profit for 249 items will be negative 2 times 249 squared plus 997 times 249 minus the 1599, and it turns out my profit will be $122,652. It is money. So this would be my maximum profit. Now we want to talk about the average cost. Now the average cost is the cost per item when X units are produced. So that is the quotient of the cost function, the total cost of production, and the identity function f of x equals x, the number of units produced. So it makes sense. The average cost per item is the cost divided by the number of items you produce. And notice the symbol for the average cost function has this line above the C.